Hi, my name's Dan Wheatbrook, founder of the Bear River Rocket Stove Company. If you have any questions, just holler. I'll tell you about the development of this. It all started when I was told to develop a method to feed a lot of people using no electricity or propane. And I had never heard of a rocket stove. At that point, I just started Googling cooking without electricity and propane, and I found rocket stoves. My first one was just a 5-gallon bucket, and it was made out of metal, and I took a 4-inch stovepipe, 2 feet long, cut it in half, got an elbow, cut a hole towards the bottom of the bucket, and a hole in the center of the lid, filled it full of ashes, took a 303 can, flattened it out, cut some ears so it'd slide into that round pipe. And that was my first rocket stove. And I felt so good because it worked. It didn't work very long, but it did work. It had a real short cook time before you had to stop cooking and clean out the coals because it would clog the air up. But I remembered I was told to cook for a lot of people. So I made 10 of those. And I sat back and I patted myself on the back and I said, "Good job, Dan. Really good job." And I was told, "No, go bigger." And I went bigger to an 18-inch wide griddle or cooktop to 30 inches long, and I put a 4-inch stovepipe on it, about 6 feet tall. And I went from a 4-inch rocket stove to a 6-inch rocket stove. And I put in a lid right in the cook surface because it's not a griddle, because you can't do bacon on it because the grease would drop down into the fire. You'd have bad things. But it is the handiest thing. So that was number 2. And I still have that and I still use it. It's great for doing a wok. You take that lid off, you put the wok right there, it's just right above the rocket stove, and man, you can wok to your heart's content. Now I use this, and this is a flat wok. But that one was fun. I got it built, and I was told to go bigger still. So I went to a 2-foot deep by 4-foot long griddle top. And I went to 2 big 6-inch round rocket stoves. And I got it so hot, it was like you put 2 dinner plates upside down on this 1/4-inch plate steel. It warped it. It was crazy. Well, I did turn it upside down and cut all the baffles out of it and welded it back up and tried it again and did it again. So I had to throw that one away, and then I came out with number 4. And number 4, I put a little bit of an oven in there. And the oven took about an hour and a half to get up to 300 degrees, unacceptable. But the whole thing warped. These are expensive. This is 1/4-inch plate steel, and you got to pay somebody to cut it. You got to buy the steel, and bend it, and then weld it up, and it was an ordeal. And we had the 2 rocket stoves right here, and the oven was right over there. Then a friend came over, and he says, "Dan, why don't you add a 3rd rocket stove just for the oven?" And that's where that one came from. And then when you're standing right here, cooking for a couple of hours with those rocket stoves right here, wow, was that unpleasant. It got really hot. So my boy came up from Fort Worth, Texas. He said, "Dad, why don't you just move those rocket stoves around to the end? Quit baking yourself." So we did, and it worked. And then we had, the next problem was the round. A round pipe is not a good solution. It's not a good shape for a rocket stove because it cuts off so much of the volume. So we went to square, and square is where it's at for a rocket stove. Now, then the next problem was we'd get this end right above the rocket stoves to about 900 degrees. And this end would be about 200 degrees. And that is just totally unacceptable. It would just, you put anything on this end, it would just burn it just like that. And we solved the warping problem by saying a prayer, and I just saw in vision what the bottom of this griddle should look like. Went to the fabricator, my friend Shannon, and told him what to do. He did it, and we haven't warped a griddle since. With the temperature problem, I said another prayer, saw another vision, and this time we had to change the whole insides of the stove. I went down a father and son's outing, a steak father and son's outing. There were 100 boys there. I was invited to cook breakfast for them. And this was at the ATK, where they make the rockets, the booster engines for the shuttle. A bunch of brainiacs out there, really highly educated people. And this guy was really looking over the quality, and he just was really admiring it. And I says, yeah, during the process of developing this, I went to a student who was getting a PhD in mechanical engineering, thermodynamics, and heat transfer. And I asked him, how can I get the temperature inside the oven to be even everywhere, front to back, top to bottom, side to side, without any electricity or moving parts? He says, well, what did he tell you? I says, I waited for 2 months. He didn't tell me anything. What did you do? I said, I prayed. It was really just like in the scriptures. Why go to man when you get the answer straight? So that was fun. That part was fun. Well, anyway, during that morning, it started raining at 4 o'clock, drizzling. 4:30 it was raining. 5 o'clock it was a downpour. And we had 100 hungry boys and fathers. I had 2 of these. This is a 3-foot griddle, and I had the big one, the 4-foot griddle. The wind was blowing. One of the bishops had brought a trailer-mounted professional stainless steel griddles, had 2 of them on there, propane powered. He never even tried to light them off. Never even tried to light them. One guy says, well, you don't have enough griddle space there. I'll go home and get my griddle. He went home and got a propane griddle. It was about 2.5, 3 feet wide. Got it hot, got it covered with scrambled eggs, and the wind changed. And blew his fire out. And he couldn't get that thing going again. He kind of sheepishly came over to me and says, do you have room on your griddles to do the scrambled eggs too? We did 36 dozen eggs, 300 sausage patties. We made about 300 to 350 pancakes, and we cooked up 22 pounds of hash browns. The stake president was my man splitting 2x4s and 2x6s down into little kindling. We used about 3 buckets of kindling during all that rain, the wind, everything. It did not affect the performance of these stoves. Yet the propane griddles wouldn't perform at all. These really work. And that's what you need to remember about these stoves. When times get tough, emergencies, whatever, these stoves will feature. Plus, they're just a lot of fun to use. I mean, this gets you a lot closer to where your food comes from and how to prepare it. It's just, the first time I took my big griddle, the 4-foot, and prepared breakfast for my wife and I just lit off the front rocket stove. It heats the front half of the griddle. I just did some bacon, eggs, hash browns right here, just real quick. Just lit it off, it got hot, cooked. Came back with some water, wiped it down, came back with a little oil while it was still hot, and seasoned it. And that was it. It was fun. I cooked the whole meal without any dependence on gasoline, diesel, trucks, foreign oil powers, government regulations. It was just freedom. And it's so much fun. So then we came up with number 6. 6 was between where we were developing the airflow, changing that around. And we didn't get it right because it would just take too long to get the oven hot. So number 7, this is number 7. Number 7 works. We got it dialed in, and it works. That's about all the development. Anybody got any questions about how to develop a rocket stove? And say, if anybody wanted to build a rocket stove, you would be miles ahead of me because you can see the finished product. When I started, all I saw was a bucket. Okay, that's a good thing. For the last 3.5 years, my fabricator has been telling me these are not assembly line. We don't have a great big warehouse full of them. We don't have people just welding one part and passing it on down and welding the same part. It takes a good, skilled craftsman. That's what Shannon is. Been welding all his life. Takes a lot of pride. And he starts with a pile of parts, and he creates each stove by hand. His welds, this stove weighs 600 pounds. And that's its biggest drawback. You're not going to pick it up and put it in the back of a pickup and drive off with it. But that's its greatest asset. Because that 600 pounds of steel in this stove, once it gets hot, it stays nice and even. Sometimes you'll get to talking and cooking, you'll forget to tend the fires and they'll go out. Now, by the way, that's the only time you'll generate smoke while it's cooking once it gets hot. Because as you restart the fire, it'll smoke for a little bit. But as long as you pay attention to what you're doing, it doesn't do that. 3 times this summer, I got busy. I had helpers, 12-year-old boys, and I had them taking care of that rocket stove on that end, which heats the oven. And I said, you just keep that fire going. They did. They pegged this temperature gauge at over 650 degrees in the oven 3 times this summer. It works. It really, really works. The construction, it's just solid. I've been around to a lot of shows, and people who know, metal workers, fabricators, they came up and give me all kinds of compliments. I wish I deserved them, but I don't build them. I just had the other day, a guy came up to me and asked me, where do you get these powder coated? That's not powder coated. That's a 16-year-old boy, Shannon's grandson, paints these. That's the quality. He doesn't let his grandson off easy. He just makes him do it over and over. Look at the welds here. Look at the thickness of the steel. This is solid. This is not throwaway. It's not going to last for a couple of years, and then you just take it to the scrapyard and you'll buy a new one. This is built to last for generations. Like those old-time stoves our grandmothers and great-grandmothers used to cook on. That's what this is. This is well built. Guaranteed. It's easy to move around because it's on real heavy industrial casters. The oven, I might as well tell you a little bit about. This oven is 2 feet wide, 2 feet deep, and 16 inches tall. This is the stove that we used in our video where we cooked and baked the turkey for 4 hours. This was the stove we used, this model. When I opened that door, it was 22 degrees, and this is another thing just reminded me. There's some vents in the back. We originally put those vents in the back to control temperature in the oven. We put one low and one high. They don't work. But what they do, and do it very well, is that either keep the moisture in the oven or they let the moisture out of the oven. When we did the turkey, those vents were closed, and that trapped all the moisture in with the turkey. So when it came out, the white meat was more moist than the dark meat is normal. It was delicious. Just fall apart. It was just laying there, the breast was falling off, the legs were falling off. Oh, it was a fantastic turkey. I love it. You can see this is 1 inch of fire rope. So this completely seals this oven off. There's no smoke in here. There will be a little bit of smoke because you season this with oil just like you do the griddle. Not as often because it doesn't get exposed to water. But when you do start cooking and baking in the oven, you will get smoke as that oil burns off. But that's no big deal. None of this smoke goes in here. Then that rocket stove on this end is the one that heats the oven. These two on this end heat the griddle, front half and the back half. You always have to light these two off first before you can light that one off. Because that one we're changing the direction of the hot gases 5 times and we're making it go down. It doesn't want to go down. So there's not enough draft to light that one off without these two going. On this stove, this model with the 3-foot griddle, once you get this unit hot and that one's going and these two are going, you can let these two go out if you want to spend the day baking bread or cookies or whatever, and just keep that one going and it will keep the stove, the oven going. I haven't tried it on the big one, but I don't think it'll work because there's 14 feet of travel on that one because it's so big. I don't think it will work with just the one. But I haven't tried it yet. A rocket stove. I just take for granted now that everybody knows what a rocket stove is, but most people haven't ever heard of it. A rocket stove is just an elbow. We started out with round pipe with a shelf welded in there about 1/3 of the way, and that just cuts off too much air too quickly because the ashes build up, and then you find yourself stopping the cooking process, scraping out the ashes so you can get more airflow, and that just doesn't work. We went to square tubing, and the shelf is right here. You always put the wood, the kindling, on top of the shelf. The air goes down here, and it's important to keep that clean so you have airflow going through all the time. If you notice you start making smoke, it's because that airflow, air passage gets blocked off with ashes and coal. So all you have to do is take a stick, go in there and scrape the ashes back, and you'll be amazed at how few ashes there will be. We cook for 4 or 6 hours at a time, and there might be that much ash left over in each rocket stove. Now I was made aware of how unique this is the other day when I was looking at my friend from Portland, Oregon. He markets a rocket stove made out of 6x6 square tubing, and he put a dump door on the bottom. And he says, now as the ashes build up, all you have to do is trip this little switch, the door flops open, all the ashes fall down. On his driveway in front of his house made a huge mess, and then you have to light the fire again. Well, I noticed that with my my round one and my steel buckets, that I could only cook for about 15-20 minutes, and I would have to stop and clean them out. With this, I tried to figure out what is the difference between this rocket stove, which I can cook on for days and not have to clean it out, as long as I'm watching what I'm doing. And that one, which has to be cleaned out regularly, even though you're giving it full-time attention. And I think the big thing is this is insulated, it's longer, it's bigger, it's heavier, and it gets hotter. And we get air flowing through there like crazy. So it just consumes the fuel more efficiently, which is wonderful, see, because you don't have to clean it out. This down here, these legs, this corner is reinforced with 1/4-inch plate steel so the legs don't collapse. When I took the number 3 stove out of my truck, went down the ramps, the legs were about 3 feet tall. And as soon as it hit the concrete, those legs became collapsible legs and like a table. And so we straightened them out and turned it around because I wanted to go on the grass, see how they do on the grass. And as soon as I went from sidewalk to grass, the other 2 legs folded up. All this in a learning process. You know, it's very expensive, but that's what it takes. On these stoves, this will be part of the cleaning process. We have a grease tray right here, and we put this little bucket right here to catch the grease. But eventually, the fly ash from the stoves will build up. It'll build up in 2 places. It'll build up on top of the oven, and it'll build up under the oven. You see this here, that's a plenum, just like a heating duct in your house. Okay, it just conducts the hot air around that oven. But that's the lowest point in the oven, and that will eventually build up ash in there, and it'll reduce the flow. So some year when you notice your oven is slow, it's not cooking as well as you used to, there are 2 cleanouts underneath. And you have to access them from the back. You have to take a stick or a hammer or something and knock them out because they're intentionally made really tight fit, so there are no air leaks. And you just take a rope, well, up top here you take these off, take a stick that's flexible, put a rag on the end of it, and push it all the way through. And then the ash will fall down here, and it'll fall down on top of the rocket stoves. No big deal. Once it falls down here, and you do the front, then you do the back, you take a rope, and you fish it through all the way until it falls out this one. Then you tie a rag to it, and you pull it back. Then you get all the ash out from the top and the bottom. Put the 2 slides back in. How often you have to do that will be depending on how much you use it, what kind of wood you're burning. You know, if it was a real situation, you could use anything, corn cobs, pine cones, buffalo chips, whatever comes to handy, whatever's combustible. Of course, nicer wood is much easier to use. Now I just found a source of wood. This is what I tell everybody to use, and this is what I've always used, is stuff like this. This long and about this big. Big as my thumb, long as my forearm. This really burns hot. And the key to the amount of heat that we're putting out is we get into a gasification process. When you're burning in a rocket stove, you'll notice this whole log does not catch on fire and burn all at the same time. We're only burning the tip. And we've got this air coming up through the bottom, coming up, blowing past that fire. So it's constantly fed oxygen. You notice the old blacksmiths, how they'd have a bellows and blowing on their coals when they want to get steel hot. That's exactly what we're doing in principle. So because of all that air gets going, we actually force the gas out of the wood, and that's what we're burning. We get complete combustion, That's why there's no smoke. Now, if you burn a big piece of wood like a 2x4 or 4x4, has a cold center. This wood is not big enough to have a cold center. It's going to get hot. It's going to burn very nicely. Actually, the smaller the wood, the hotter your fire. And this, I was so fortunate to find this because this is all hardwood. It's not pine. Although we did cook a whole dinner one time using half of a sagebrush. It worked great. That was really a hot fire. But this right here is borderline too big. When I burn this, I'll just take my hatchet and split it down. If you were to put several of these in like this, you never ever want to stack the wood all the way across solid like this and push it all the way in, because the combustion chamber's down here. And if you did that, it'd block off all the airflow. It wouldn't work. So I would stand these like this. If I had to use stuff this big, I would try to mix it with stuff this big. And I'd maybe put a couple of these across the top. But smaller is better. Although there's some videos on YouTube right now where Mother Earth News is using a stove, and they ran out of wood, so they just went and ripped the boards off of a pallet, nails and all, stuck the whole boards in there, and worked. So it's very versatile. You don't have to have perfectly cut wood. All my wood I've used looks like this because I've been a woodworker for 30 years. I've been saving wood. I've got all the tools, and I just figure I'm cutting it up now because I have electricity. This is a lot easier to prepare with electricity than it is without. But if we didn't have electricity, sagebrush is fantastic. I'll bet we have 1 million tons of sagebrush in Utah and Idaho, and that's all good fuel. Where they had that fire up here, where all those dead cedar trees are, man, that is rocket fuel. All those dead cedars and smell good. That was great. Okay. I've about talked myself out.
How about cleaning and keeping it just like seasoning a skillet?
Good question. Thank you. Yes, you're right. Just treat it like a Dutch oven. When you get cooking here, first thing I do is always when it's hot. I'll just you want to take a spatula and scrape off as much food as you can. And then I steam clean it. I just squirt some water on there, take some paper towels, and you got to use something, a long spatula or something, because the steam will get you. And then just clean it off once the water evaporates, and that'll take about that long. Then I get a little oil, and a little bit of oil. And then I take a paper towel, and I just coat everything with oil. You don't get any rust. And that seasoning stays right there, and soon it'll be a non-stick surface, just like a Dutch oven. It will approach that. Cleaning out the rocket stoves. If you do end up with some dirt in there, some ashes, and you want to get them out, just take a stick, stick it in the bottom, go all the way in, and just scrape it out. It's no big deal. The first couple of years I was working with rocket stoves, I had to clean them out every time because I didn't know what I was doing. Now, unless I really mess up or I have somebody, I'm not paying attention, I don't have much ash left over. I'll have that much ash, literally, from each rocket stove. Nothing. I don't even clean them out anymore. I just let it burn up, and the next time I fire it. These are super efficient. And the main thing to remember and the main thing to get excited about is these things work. And if you don't have all the supplies you want to have, I think the trouble's going to last 7 years, so I'm preparing for 7 years. We've been taught to have food supply. And not only food, but we have to have clothing and shoes and socks and dental care and piano lessons and We have to have all that because we don't want our children to grow up without, developing their talents and art and stuff. You'll be able to barter. This stove is the king of barter. There's not anything you can't get with a warm loaf of bread or a hot, nutritious meal, especially if you're in trouble and those people can't cook things, they don't have electricity.
Can you comment on use of the rocket stove for heating up living quarters? Besides the cooking part, will it also heat up the living quarters if it's properly vented?
It would, but it would be very inconvenient to use as a heat source.
Okay.
There's a real good application for a rocket stove in heating. It's called a rocket thermal mass heater. And those work beautifully. You burn them for about 3 or 4 hours. You heat up this great big thermal mass, and it may look like a couch or a bed or just something. And then that'll keep your house nice and toasty for 2 or 3 days. And it uses very little fuel. Very little.
Another question. Looking at all the other rocket stoves or portable or mobile wood burning stoves on the marketplace, can you comment on some of the disadvantages and problems that you've seen in those, and then comment on why the Bear River rocket stoves are going to be a better solution?
Oh, gee. Just go to a prepper show and look at those. And they're all about 5-gallon bucket size or smaller. And if you want to feed this many people, you can put 1 pan on there. And you can cook a couple of hamburgers at a time. And forget the French fries. And forget, they're very restrictive. They're very convenient for portability. Yes, you can go, and if it's just you two or a small family, that would be okay. I was told to prepare to cook for a lot of people. And some of them are pretty well made, especially the guys who just take 6x6 inch square tubing and weld up stuff. You're never going to hurt those. You'll never hurt these. These are going to last a long, long time. But this is the only stove out there, powered by rocket stoves, that has a griddle cooktop and an oven. This can do anything you can do in your kitchen, except for broil. We don't have a broiler function. You could smoke your food if you wanted to. All you have to do is get a cookie sheet, soak some wood chips, put them in the cookie sheet, and put them down there below this shelf. And if you wanted to, you could just raise the shelf, put the wood chips down there. That gets very hot, and that would smoke them. And so it will even smoke, but I tell people it's not a smoke.